Yesterday, we have completed about activity 7, that is acids and bases are conducting the electricity, right? So here that aim of the activity is to observe the electrical conductivity of acids or bases. Here, what are the required materials? Here, required materials are glucose, alcohol. Why actually I taken that glucose and alcohol? Here, ice like same your acids, glucose and alcohol also containing hydrogen in them, but they are not able to produce the ions in the water, right? So here that question may be asked you to write a activity glucose and alcohol containing hydrogen in them in their composition, but not behaves as acids. What could be the reason? Explain. So this only, right? So same activity you are following. Then hydrochloric acid, sulfuric acid, sodium hydroxide base, then 230 volts AC plug, electrodes, wires, right? Bulb, etc. Few materials we are collecting and arranging them one after the other, as you see here. So take an empty beaker, or you can use plastic mug also. Then take electrodes, make them to stand vertically in the beaker. Then do not allow them to contact each other directly, right? Then connect them with a wires, connect to the AC plug, then one of the terminal to another terminal, give connection using the bulb here. So AC plug to bulb. So here, when we fill it with a distilled water, what happens? So see here, electrodes are there. Then I'm filling this with distilled water first, then observe by switch on. So when we switch on, we will see that bulb do not glow. So remove that water, make it dry, then fill it again with another solution, that is here HCl. Then what happens when we switch on? So bulb glow. Here, the reason or the difference between distilled water and HCl is observed. HCl in the presence of water able to produce ions, diluted HCl, right? Dilution means that concentration of HCl decreased by adding of water or acid mixed into the water. So anything you can take it here. So that is the meaning of dilution. So then remove the water from that, replace that solution by glucose here, then again switch on. What you notice here, bulb doesn't glow. So in this case, bulb not glow. Then add one more solution, alcohol, same way. Here also you can notice that bulb not glowing. Then fill it with a base. What happens? Bulb glow when we switch on. So here these are the observations we made in this activity. So you can conduct this activity by selecting or collecting many sample solutions, right? Many sample solutions. You can make your observations in a list, make a list of observations. From that, you can conclude that ions produced by the acids and bases, right? And some salts also, right? But we are not considering the salts, only well-known acids and bases, right? So from that, we can conclude that acids and bases conduct the electricity. So that is the activity. Then here, we got one observation in the activity 7. What is that? Acids and bases produce ions, right? So here, do they produce only presence of water? Ions produce only in the presence of water, right? So we need to verify that. Here already we know HCl is a acid. Did you know that HCl behavior? Is it acidic or basic? HCl is an acid or a base or neutral? Reply me.
Sir, acid.
It is an acid. So what we can expect that behavior of HCl with blue litmus paper. Is there an effect on blue litmus paper by HCl on blue litmus? Please, anybody? How that blue litmus paper can affect? Will it affect or not? Will it affect or not? Don't know anyone? Abhinay, what is the effect of HCl on blue litmus paper?
Sir, maybe it will not change.
Sure. What is the nature of HCl here?
Sir, acidic.
Acidic. So acid affects the blue litmus paper or not? Go to activity 1. See the list table. Blue litmus turns into red color. Already we verified. Blue litmus turns into red color. Right? So here already we know the result that blue litmus paper changes to red in color. That confirms that acid, right? Confirms that acid, which is HCl. So here again we are verifying that HCl is an acid or not using the blue litmus paper, right? But the condition is dried. The condition is dried. The condition is HCl is a gas, not a liquid, right? So how to produce gas? Generally, we have HCl solution in the laboratory, right? HCl, a solution, liquid form. How do we produce HCl in the gases, right? So let us see that activity here. So this is activity 8. Actually, this activity 8 we are conducting for observing that ions produced only in the presence of water, aqueous water. So acids produce ions only in the presence of water or in a dried condition. That we need to verify. So for that, we are required few materials that are here simply. What the materials are here? They are the salts. They are salt. NaCl. NaCl. Please mute yourself. Someone unmuted. Harshit. Okay. So salt, NaCl. Then we are taking an acid to produce HCl gas, right? So here that is sulfuric acid. By the reaction of NaCl and H2SO4, we are able to produce HCl in a gaseous form. So required materials are NaCl and HCl, H2SO4 solution. By these two reactants, you are able to produce a gas, that is HCl. Then along with that, we required other materials also, test tube, blue litmus paper, double hole rubber cork, thistle funnel, etc. So these are the minimum required materials. Then one more required material is there, that is calcium chloride, CaCl2, right? This is required maybe only in a wet conditions of weather. That means moisture, air, right? If the air is moistured, weather is very cool and moistured, then you require a calcium chloride, right? So why here? It is capable to absorb. It absorbs water, right? It absorbs water from the air. So here you are producing the gas by the reaction of NaCl and H2SO4. We are obtaining HCl in a gaseous form and dried. So don't make it wet by the mixing of or combining of air with this HCl. So that is the condition. That's why you are suggested to or given one note, important note, use calcium chloride, right? So the purpose of using calcium chloride is make it dry. If the air present in its surroundings, that also become dry. right? So this is important caution here. Okay, then how to complete this activity? We will see that. Here, simply I required materials, right? So they are collected one by one. So first of all, I will hold a test tube. I will hold a test tube and slowly I will add a sulfuric acid into the boiling tube or test tube. So hold a test tube in your hand, then slowly add sulfuric acid with the help of dropper. So add H2SO4 dropwise slowly into your boiling tube. Right? After adding certain amount, just stop adding of sulfuric acid here. Then what to do? Just you need to enclose it because you are producing a gas. So here do not allow that gas to escape from the boiling tube. So if you keep open, what happens on adding of NaCl, that sulfuric acid react and produces a gas that maybe moves upward. So do not allow that gas to escape from the boiling tube. So to keep that gas inside that, what you need to do, what you can do? Anybody? What I need
Sir,
to?
fix the rubber cock.
Yes, we need to close that mouth of the boiling tube with a rubber cork. But I'm not added NaCl. How can I add NaCl with rubber cork after closing rubber cork? How do you add? If I close it with a rubber cork, again removing and adding that NaCl into that, it's difficult, right? So what to do? We have here thistle funnel, right? So take a double hole rubber cork, arrange thistle funnel to drop the solid materials into the liquid, right? Then fix the delivery tube to allow the gas inside. Here one must compulsory, one precaution is there. Thistle funnel, this gas tube, right? So this ending tube, bottom, must be inserted, immersed into the liquid solution. Then only it trap the gas inside. So here see, it is in contact with the liquid. Then it won't allow the gas to escape through it. Thistle funnel only allow the material into the liquid, but it won't allow the gases outside. Only entry, no exist. Right? So one way. Then what to do? I added sulfuric acid and I arranged the apparatus. Water, rubber cork, thistle funnel, and delivery tube. So the purpose of using here thistle funnel is to drop the materials inside without allowing the gases to escape from the container. Then delivery tube only to allow the gases outside, outlet, right? Then what happens if we add sodium chloride into the sulfuric acid? So observe, reaction takes place. So okay, see here, reaction is taking place and the bubbles created in the liquid. That is giving you idea about liberation of gas. What happens? That collected gas will exist through the delivery tube. What the gas is here? It is HCl gas. Then what to do? We need to observe that liberated gas behavior. So is it acidic or basic? So already we know HCl is acidic in nature. So I need only blue litmus paper. No need to take the red litmus paper. Okay. So blue litmus paper, I will get it near the gas. So gas liberates, right? So here I can put one important substance in the delivery tube. What is that? What is that I'm keeping in that glass tube, delivery tube? That is anhydrous calcium chloride to make it wet, right? So here simply that gas will be liberated here. That is HCl gas, and that gas through the delivery tube allowed to pass onto the litmus paper, dry litmus paper. What I'm taking? Dry litmus paper. Then observe, did that dry litmus paper changes its color or remains in its own color? Is it changing its color? What do you observe here? Is it changing its color on passing of HCl gas? No, it is not changing its color. So what do you say here? Is it behaving as a acid? Its behavior is observed as a acid, the liberated gas. Did you confirm that HCl gas is an acid? No, I am unable to confirm that because no effect on the blue litmus paper. If it is affecting the blue litmus paper, I will give you the confirmation HCl gas is an acid. So no effect on the dry litmus paper. Then here what I am doing here, I will get a litmus paper after dipping that into the water, distilled water. So make it wet and then get it near the gas. Make it wet and get it near the gas. See here, when you dip the litmus paper into the distilled water, some change in the color will be observed. So up to this portion only, I dipped this litmus paper into the water. Then observe, does this releasing of HCl gas will affect the blue litmus paper or not? So pass the gas continuously onto the wet litmus paper. What happens? Observe. Continue that liberated gas will be in contact with the blue litmus paper, which is wet. See here, slowly turned into the red color up to the portion what we dipped into the water. There is no effect on the dry litmus paper. Only observe the effect on blue litmus paper. Have you seen that? Have you seen that? Everyone. So here I observed the effect on the blue litmus paper, but not on the dry blue litmus paper, only on the wet blue litmus paper. See, on passing of continuously the gas onto the wet blue litmus paper, it is turning into red color. So here simply I am able to give you a conclusion here, simply that HCl gas is affecting the wet litmus paper because of that dilution of gas in the water or mixing of that gas with the water producing the ions. Right? Sir, how you see these ions here? No ions. Right? So we can realize that by the previous activity here. What is previous activity? Activity number 7. Already I observed an adding of HCl into the water, ions produced. If you take a gas HCl, right? HCl that does not conduct electricity because there are no ions present in the gaseous form. Only on mixing of that gas or the liquid of HCl into the water on dilution, then they can produce. So here I am able to give you the conclusion is here simply, first of all, you need to observe the reaction, what is taken in the boiling tube. So what are the reactants we considered? What the reactants we are taking? Reactants, please. What the reactants are here? Can anybody?
Sulfuric acid and sodium chloride.
Sulfuric acid and sodium chloride, only 2 chemical substances are considered here. Right? NaCl is nothing, the salt which we eat, common salt. Right? So by the reaction of here, NaCl with the sulfuric acid producing salt. That is simply sodium carbonate, sorry, sodium sulfate. That is what? Sodium sulfate. And we observed, sorry, typing mistake, Na2SO4. Na2SO4. It is produced in the reaction and the gas is liberating, observed here, HCl. That gas is HCl. So here simply that HCl gas does not affecting the dry litmus paper. It is affecting only the blue litmus paper. So here that is the conclusion here. So what I derive the conclusion here, that dry gas is not an acid. HCl gas is not an acid because no effect on the dry litmus paper, and that HCl is in the aqueous form. That means wet litmus paper. That gas is combining with the water molecules present on the blue litmus paper, wet blue litmus paper. That gas is combining with the water molecule and converted into aqueous solution. Gas converted into aqueous solution. Then it is affecting the wet blue litmus paper because of ions production. Right? So is it clear? Any confusion? Have you seen them clearly? Everything observed very clear? Activity 8? Yes. So no confusion. No confusion. Right, thank you. So we will go for another observation here. I given you conclusion. Only aqueous solution of HCl is behaving as acid. Actually, what happens when acid mixing with the water? Right? So here dilution of acid. So here simply ions produces. What ions produced actually here? H plus ions expected. But actually, do they produce H plus ions or any other ions? Let us see here. So here, H plus ions do not exist in its isolated form. That means cannot exist as bare ions, as single, right? Do not left as H plus ions. They can combine immediately with water molecules. Nearly it is 3 to 4 or more than also, right? So they can combine with the water molecules. Simply that hydrogen ions are produced by the adding of HCl into the water. So they can immediately attached by the water molecules and left as H3O plus ions. Let us see here. HCl added into the water. What happens? They can produce ions in the water as H plus and Cl minus actually. But here H plus ions do not left as here H plus ions. Immediately that H plus ions will be combined with H2O ions, H2O water molecule and left as H3O plus ions. So that's why you are not writing here as H plus ions. HCl on mixing of water, what happens? They expect it to be as H plus and Cl minus ions, but here immediately these H plus ions are combining with H2O water molecule and they are giving you as H3O plus ions. So this is the reason for writing of this HCl and H2O reaction giving you as H3O plus and Cl minus ions. Is it clear? Why that equation written as like this or any confusion? Right? So here simply that equation will be written like this, ions production. Then here simply what happens if you add base into the water, dissolved in water, NaOH added, right? So here NaOH also produces ions, right? What type of ions? Here, especially basic substances will produce OH minus ions. But NaOH in the water produces Na plus and OH minus ions in the water, right? NaOH produces Na plus and OH minus ions in the water. Then here simply that any base. By observing one more, we can confirm that here potassium hydroxide. What is the potassium hydroxide nature here? Basic in nature. An addition, that dilution or dissolving of this potassium hydroxide in water will give you OH minus ions and K plus ions. Sorry, K plus ions here. K plus ions. So you are getting common ions on dissolving base in water. What they are here? Generally, what you are observing? OH minus ions given by the bases. OH minus ions given by the bases. What about acids? If you add H2SO4 in water, what happens? Dilution of H2SO4. Here, they are also same. What happens here? They can left as H3O plus ions and SO4 2 minus ions here. So these are producing ions. Maybe you observed ions in a ninth class, atoms, molecules, and the chemical reactions. They are given with a table, right? Ions, right? So observe once again what type of ions you are expecting, right? So here simply bases are giving you OH minus ions and acids are giving you H3O plus ions commonly. For any acid with water or for any dissolving of a base in water, we can expect OH minus ions. Acids, H3O plus ions. So you can write H plus or H3O plus, not a problem. You can write in your exam like this, H plus or H3O plus ions. Any confusion? Any confusion in understanding activity 8? Give me your reaction. Go to quick reaction. So no confusion, right? So next topic for us, that is here activity number 9. Activity number 9. So what is activity number 9 here? I said in the activity 8 or in the activity 7, dilution of acid. Dilution of acid. So here maybe you are confusing. What? So dilution means mixing with the water. So acid mixes with the water or water mixed into the acid. In what way we have to add, right? So which is the correct method, right? So to know this one, first of all, we need to know one thing. What they are here, exothermic, endothermic reaction. What is exothermic reaction? Can anybody? What is exothermic reaction? Exothermic
Heat liberation.
Heat liberation, right? Exothermic reaction is what? Heat liberation. Endothermic reaction, heat absorption. So here, adding of acid into the water, adding of base into the water, or water into the base, or water into the acid, in any combination, that will produce large amount of heat energy. Large amount of heat energy. So here, the method suggested to us for dilution of acid or base, simply always you can add a solute into the solvent. Solute into the solvent. So what is solvent here? Universal solvent is there. In your 9th class, you learned. Is matter pure? Is matter pure? Chapter. What is that? Simply, solvent is, universal solvent is water. Anything it can dissolve. Maybe it takes less time or more time to dissolve in it, right? So here simply water is said to be universal solvent. So maybe you got it. Large quantities solvent, less quantities solute. So which you can mix into another for dilution. Can anybody? I said solvent. Solvent is what? Water. So anything dissolved in water. So slowly you can add solute into the container. So what to do in this? Simply you can take a beaker. You can take a beaker, right? By taking a beaker into that, you can add slowly what? Acid or the base. So I'm taking a container, for example, here. So I'll give you experience also. Same as a beaker here. So now it is just looking like the beaker, right? So take a beaker, then take one glass rod. Take one glass rod for a constant stirring. Place it. Then add some certain amount of water into this container, right? Just add water up to certain level in the beaker. Okay, water added. Then what to do? Take your solvent. Take your solvent. Slowly add dropwise from your container or using the dropper. Then what to do? Continuously you can stir it. That liquid must be stirred on adding of solute into the solvent. Solvent is water, solute is small quantity that which you want to dissolve or dilute. So HCl or NaOH, whatever it may be acid or base. Why we are following like this? To decrease the effect of acid. What happens, sir, if I add together large amount of solute into the solvent? What happens? It releases high amount of heat energy. It releases large amount of heat energy. So that large amount of heat energy liberated by the acid and water combination will affect the container. It sometimes break the glass. So that acid may spill. That glass pieces may be affect your body, right? So that's why here always you need to follow the precaution. Adding of acid into the water is the right method, not water into the acid. Always you are adding acid into the water, not water into the acid. So here simply it is highly liberating heat energy, producing heat energy. So the process of dissolving an acid in water is an exothermic reaction or exothermic process. So you must always add, right, acid to the water with constant stirring to decrease the effect of liberation of heat in the process. On glass container, you are stirring constantly, so that can reduce the temperature of the liquid, right? So here on acid bottle, you may observe one precautionary step. This is, see here, what happens? Unfortunately, that acid spills on your skin. It is corrosive in nature. It can burn your skin, right? So that is the reason to give this symbol on the acid or base bodies. One more, this symbol. So this black colored one is metal rod. On metals also it can affect. For example, for bathroom cleaning purpose, you may purchase acid bottle, green color bottle, white color bottle. Use that acid, take one iron nail, new iron nail, keep it in the acid for some time, then recollect that metal, you are able to break it easily. That strength of metal gone. See how stronger that acid or base. So that is the reason to give here this type of symbol on the bottles, right? So it corrodes the metal also, corrosive in nature. So that's why you can see a triangular symbol on the bottles that is in yellow color. Then in the triangle, you can find these symbols. So this is warning to you. What? Corrosive in nature. So this is activity number 9 clearly. Did you understood that activity 9? Activity 9. Is it clear? So everything is clear, I think. No confusion. Right? So this is about today's class. We'll meet in the next class by tomorrow. In that, I will explain you activity 10 and about a pH scale. Almost I will discuss tomorrow up to the activity 12 or 13. Okay, if possible, that animations are not there. Without animations, I am not interested to explain. So that is the reason to stop this class for today. Is it okay? No animations. If you want, I will continue without animations also. How you are expecting the class without animations also? Shall I continue or shall we stop? Okay, let us stop for today. If not possible to me to make animations, I will continue without animations also, because I don't want to waste your time, right? So at any cost, I'll complete by April first week, as I promise you. Okay, so thank you. We'll stop for today.